We're using CUDA to speed up our processing of ultrasound signals for our whole breast ultrasound system. So this is a system that we hope will be used by radiologists in conjunction with mammography and ultrasound and all the other existing technologies to help radiologists make better decisions about breast cancer care and treatment. I looked at CUDA late 2006 when I saw an announcement, actually on Slashdot, kind of about the beta coming out. And I'm not a typical supercomputing attendee. I'm doing production level code, stuff that has to be maintained. It's medical quality code, so it has to be maintained and kept up for 7 years or more. So when I heard about CUDA, I thought, we're using clusters right now to do all of this processing, and it's taken a couple hours to get each scan processed. It's a long time, and a cluster is kind of a complex thing to keep up and running inside a medical device. So I thought, why not try this? It'll cost us $500 to go pick up a video card. It'll cost me a little bit of time to kind of get up to speed on it. And I already know C, C++, I was familiar with that. Had a little bit of MPI experience from working on that cluster, and got approval from our COO, went and bought a card and spent a little bit of time here and there working on it. And got our entire algorithm ported over to CUDA, and saw some significant speed-ups over the cluster we were using, and even over a new cluster that we were going to be putting in the system that we had planned to get a speed-up on. So it was quite nice. We went from a couple hours of processing time on a 7-node Pentium M cluster. We were going to cut that down to about 45 minutes on a 16-node Core 2 Duo cluster. Meanwhile, CUDA on 4 graphics cards were giving us processing times of about 20 minutes. So it was pretty much a no-brainer from the speed point of view, and also from cost. That CUDA setup, putting in the system, cost about half as much as this 16-node Core 2 Duo cluster. So, between speed, cost, power consumption, we decided to go with CUDA. There was some resistance, to using this. They'd been used to developing on the cluster in Fortran, and they'd been used to the idea of running their code on the production system on the cluster in Fortran. So, to take that tool away from them kind of gave them a little bit of heartache. They weren't real happy about that. What we found, though, was with CUDA, since it's C, we could write basic building blocks of their algorithm in CUDA and in C, and give them C-callable functions that they could use in their Fortran code. They're kind of moving towards that now, but they also have an executable that stands alone and runs their entire algorithm that can take different inputs, different iteration numbers, different frequency sets, and just run their algorithm outright. When they started using that, they were able to do multiple runs in a very short amount of time on the Tesla hardware, tweak parameters, try different things, and they're now really excited about using the hardware, not just in production, but now in their development. And obviously, since I'm developing the code, I use that hardware every day to do runs, make sure the code is correct, try different parameters, process scans that have come back from our clinical sites when we need to redo various aspects of it, or we want to try something a little bit different. It's been great for all of us. We were using 4 GPUs, and we got processing times of around 15-20 minutes. Since that time, we've kind of changed our algorithm a little bit, added a few more iterations, changed a few things. That upped our processing time on 4 of the previous generation GPUs to about 28 minutes. Still pretty good, still very fast. We took out, on my development system, we had an S870, so 4 previous generation Tesla GPUs. I unplugged those 4 GPUs and put in a single C1060, so a single card. That single C1060 did the same processing job in 30 minutes. So 4 old generation GPUs at 28 minutes, 1 C1060 at 30 minutes. It was just phenomenal to us. It actually opened up some new avenues for new development. So now we don't need all this space inside of the box for 4 GPUs. We don't need all these cables going back and forth from our GPU host to the GPU the desk side GPUs, we can actually integrate 2 C1060s inside one box, no cables, no trouble, less space, less power, and still get double the speed up that we had before. So it's not just great from a speed point of view, but it's actually helped us quite a bit mechanically and power-wise in our system design.